In this video, we'll see how we can apply Excel to find the confidence intervals for proportions. We use the z-distribution when calculating the confidence intervals for proportions. In Excel, we can find the confidence intervals by using the XL stats or the mega stat add-in, but instead we will use a manual procedure in this tutorial. To find the lower bound, we take the sample proportion or the p-hat value minus the margin of error, and to find the upper bound, we use the sample proportion and we add the margin of error. Now, the formulas are p-hat minus and p-hat plus, and z alpha over 2, this is the critical values, and we multiply to the square root of p-hat, q-hat. Q-hat is just the complement of p-hat, which is 1 minus p-hat, and n is just the sample size. Okay, so below are the steps. Now, we have the alpha, which is the significant level. So we have half of the alpha on the left tail and half of the alpha on the right tail. So together they are 1 alpha. Therefore, the area in between must be 1 minus alpha. Remember, the area under the entire curve is 1, right? All the area under the curve is equal to 1. And 1 minus alpha half and alpha, which is 1 minus alpha. So that is the remaining area in the middle. To find the p-hat value, this is the sample proportion. We take the x divided by n, and where x is just the number of the sample units that has the characteristic of interest, right? And to find the n, we just look at the sample size. Okay, for the left critical value right here, minus z alpha over 2 at this point, we use the inverse norm function, which is norm.s.inv. This is the z distribution. Therefore, this is the standard normal distribution, and therefore we use the s, letter s here, including here, because I'm looking for the standard normal distribution. So norm.s.inv and alpha over 2, which is the area to the left side of that critical value. So the area on the left side of that critical value minus z alpha over 2, this left area is alpha over 2. And then to find the right area, we just have to put a minus. It is missing a minus here. So put a minus here to the left critical value because they are symmetric. So whatever you get for the left critical values, we just take the opposite value of that to get to the right critical value. Okay, so after we have that, we just apply the formula. We take p-hat, we subtract the z alpha over 2, and we multiply by p-hat, q-hat divided by n. And you can use Excel for these calculations. So as long as you can find the left and the right critical value using the these functions, norm.s.inv, and then you can apply these two formulas to find the margin of error. Okay, let's take a quick look at this example. Suppose that a market research firm is hired to estimate the percent of the adults living in a large city who have cell phones. 500 randomly selected adult residents in the city are surveyed to determine whether they have the cell phones or not. And out of the 500 people sampled, 421 respond yes, they own the cell phones. Now, using a 95% confidence level, we want to compute a confidence interval estimate for the true proportion of the adult residents of this city who have the cell phones. Alright, so going back to what we saw earlier, we need to find the sample proportion p-hat, and we need to find the critical value z alpha over 2. Okay, so open Excel. I'll find p hat first. Now p hat is equal to what? It is equal to x over n. And x is just the number of the sample unit that have that characteristic that we are looking at, right? So in this case, we look at this problem. Out of the 500 people sample, 421 people would say yes, that they own a cell phone. So this is the sample size. The sample size is 500. So I have the sample size, it is 500. So to find the p hat value, I press equal, right? I'm looking for the ratio 421 divided by 500. And that is my p hat value. And then I also need to find the q hat, which is the complement of p hat. So it's equal to 1 minus p hat. Now I'm looking for 95% confidence interval. So my alpha is the order 5% or 0.05. Let me just put it over here. So alpha equals 0.05 because we are looking at 95% confidence level. So alpha is the order 0.05. And if that is the case, then my alpha over 2, right? We are looking for alpha over 2, and that will be equal to alpha divided by 2, and this is 0.025. Now next we need to find the critical value. So the left minus z of alpha over 2. This is the left critical value. Oh, sorry, we shouldn't name it that way. Let's just say left critical value. Okay, to find the left critical value, go back to here. We use the norm, right? We are looking at this point, so we use the norm dot s dot inv inverse norm, and we input the alpha over 2, which is the left area. So I input equal, right? I input equal norm dot s dot inv, and then my left area is alpha over 2. So I click on alpha over 2. So I have the minus, right? Minus 1.95. And for my right critical value, that would be, it's just the opposite, right? The opposite of this value. And that is going to be 1.95, right? Minus of this value, because they are symmetric. One is minus, the other one is plus. Okay, we have everything. So now we can input this formula to find the lower bound. So here, to find the lower bound and the upper bound. Okay, so make sure you press equal. I use the, you know what, actually, let's try to find this term right here. It's easy to find this term first. So we're gonna find the, actually no, let's do it together. So equal p hat, right? P hat is this value minus, and then we multiply these two terms, and we take the p hat minus that. So I put everything inside a parenthesis, right? So z alpha over 2, this is my my critical value, right? So because I already put the minus outside, so that should be just the z alpha over 2 or 1.95. And then I multiply with the square root. So I use the function sqrt. This is the square root function. And then I have p hat, which is this one, multiplied to q hat. Okay, q hat is this one. And then divide by n. N in this case is 500. I believe it's 500. 500 people. All right, so divide by 500. And close that. And then don't forget to close the whole thing, because we open it here. So close it again. And that is your answer, right? The lower bound is 0.81. Now we can just copy the whole thing, and then we go down here, we press equal, oops, sorry. Okay, go back here, I can copy this, and then I go down here for the upper bound, I double click, I just paste what I copied up there, and then the minus, I just change it to the plus because I'm looking for the upper bound. So I delete the minus, I change it to the plus. So my upper bound would be 87, 0.87397. So this is my lower bound and this is my upper bound of this proportion.